Okay, question 4. At a stall in a fair, contestants have to estimate the mass of a cake. A group of 10 people made estimates m, and for each person the value n minus 5 was recorded. The mean and standard deviation of m minus 5 were found to be 0.74 and 0.13 respectively. Right, write down the mean and standard deviation of m. Okay, well what we've done is we've recorded m minus 5. Now what that's done is it's shifted the data downwards. It's not altered the spread of the data, it's just shifted it. So all that we find is that when we want to work out the mean of m, we need to add back on that 5 that we've taken away. So the mean will be 0.74 plus 5, which is 5.74. But as I said, the spread hasn't been altered at all. So our standard deviation would remain exactly the same as being 0.13. Now, the mean and standard deviation of the estimates made by another group of 15 people were found to be 5.6 and 0.19 respectively. Calculate the mean of all 25 estimates. Of course, we can't just find the mean of the two groups here. What we need to be able to do is to work out what the total of all of the estimates was. That's the key thing from this. So we had 10 people having a mean of 5.74, so that must have been that total divided by 10 to give that mean, and we had 15 people with a mean of 5.6. So if we work this out, 10 lots of 5.74, can't quite believe I've just done that on a calculator, 57, I did it wrong as well, 0.4, and 15 times 5.6 gives us 84. So the total of all of the answers was 141.4. So what that means is that in order for us to work out the mean, we need to do that 141.4 and divide it by the total number of people, which was 25. Divide that by 25, we get 5.656, or 5.66 to 3 significant figures. Job done. Now Fiona claims that if a group's estimates are more consistent, they're likely to be more accurate. Given that the true mass of the cake is 5.65 kilograms, comment on this claim. We've got two groups to compare. The first group, we had a mean of 5.74 and a standard deviation of 0.13. The second, we had a mean of 5.6 and a standard deviation of 0.19. And so what can we conclude from this? Well, the first group is more consistent because their spread was lower, their standard deviation was lower. But the second group were more accurate. Than the first. Their mean was closer to the actual value. So there we go. Do we think her claim is valid? I think we do. But we needed to comment on this claim. There we go. We don't seem to have got that. Happy with that. Okay.